My name is Christopher Tull. I'm here with my colleagues David and Patrick. We were gonna originally planning to do a co-speaking thing, and they just abandoned me and they're like, hey, why don't you talk the whole time? So maybe it'll be smoother, but hopefully it works out. The first half hour-ish or something, I'm gonna talk a little bit about public data infrastructure problems, some of the work that we do at ARGO, stands for Applied Research in Government Operations, and then talk about this tool called Apache Airflow that is for building data pipelines to manage some of that public data infrastructure complexity. And then after that, we're going to get a little hands-on, and I don't mean hands-on keyboard. I actually mean we brought cardboard and little paper things. So we're gonna build paper data pipelines. We figured you guys have probably been coding all day, so you'll get to think in DAGs and break into groups and have some group therapy about your data infrastructure problems and how you might be able to solve some of them with a tool like Airflow. So yeah, so as for the talking part, give some context, like I said, talk about some of our work and then the workshop. So if you have worked in government and you're trying to maybe do a data project where you pull data from different systems, keep this data in sync, join this data together and manage some of that complexity, you may have at times felt like the people on this poor ship being torn in different directions by data systems that are sort of out of your control. And just know that you are not alone. This is a common problem, trying to pull, whether it's systems in your agency or mixing stuff in your agency from external stuff. So there's a tool that we're going to be talking about called Airflow that started as a project at Airbnb for managing a lot of their data infrastructure and their data pipelines. It's now an open source project, and it has become over the last few years sort of the de facto standard among at least a lot of tech companies who are doing data engineering and data pipelines. So the idea is that by being really explicit and giving you this great way to visualize and graphically control your data pipelines, you really help to manage some of that complexity and yeah. So Airflow has, it's still getting its foot in the door in the public sector, I think, but the city of LA uses Airflow. Hunter would be the person to ask about that. San Diego also uses Airflow to populate their open data portal. We were actually, really inspired by Maxime at San Diego, and by a blog post he wrote a couple years ago talking about how they use Airflow. So it's gaining ground in the public sector. And hopefully after this, maybe you'll find a use for it yourselves. So before diving into the details of that, I want to just talk a little bit about what we do and how Airflow fits into our operations. So to start on that, ARGO is, we are a nonprofit, and we operate a data platform for integrating data across local governments and deploying data science tools. We do data sharing with researchers, and a lot of our work, the majority of our work, is with water agencies, I guess, the local water retailers across California. And in the past, a few years ago now, there was this large drought. There were a lot of issues with water, and there is this belief that we share that with better data, you can, better manage your resources. I'm sure you all are in agreement with this sort of hypothesis. And water in particular, and some would say it tends to be a little behind the curve, in some regards, at least compared to maybe other utilities like electricity or something, where they have had to deal with higher frequency data for longer time periods, and they're larger. So we work with this coalition of local water agencies called the California Data Collaborative, and they were really pioneering in starting this organization. And really, the CADC is about water managers who are trying to sort of surf the digital tsunami of the 21st century and come to terms with how do they make use of all the data that they have and all the data that is out there in order to better manage their water resources. And we, as a nonprofit data platform, provide the data engineering skills and the platform that helps them do some of this. So California's water industry, as some of you may or may not know, is extremely fragmented compared to, like I said, electricity, for example. In the electricity industry, maybe roughly like 80% of California's population may be served by 3 large electricity suppliers or something like that. California, it's not nearly that consolidated. This map here shows the 410, 11-ish major urban water retailers that have more than 3,000 connections. And these are just the major ones. There are actually thousands of them, of water districts, ranging from, say, a Boy Scout camp in the mountains that is its own entity and supplies water, up to LADWP. And all of this fragmentation makes it really hard to sort of look across the industry and make comparisons and be introspective in that regard. So some of the current state of the art in terms of data in the water industry is some data maintained by the State Water Resources Control Board, where they'll just say have like monthly data for each water retailer. And maybe they'll, so it'll be like LADWP with 4 million people is like one data point, right, for the month of June. And then some little district out here in the Central Valley is also one data point. And so you lose a lot of the nuance there. So what we do is we go down to the meter level and we get the data that they're already collecting, which is metered water use data. How much water did this household use in this month? And we aggregate that across retailers. And so while it's the same data, obviously it's in very different formats. Everybody's got a different billing system. They all have their own rates for classifying customers. And so here's sort of the marketing level view of our data platform. The basic idea is you have all this heterogeneous data. It comes in. These gears, I guess, are the Airflow, the ETL that we're talking about today. And then you standardize it, get it in the same spot, produce tools and analyses. And I guess really the industry is, the water industry, is very familiar with, much more comfortable with building physical pipes and maybe physical water storage than they are with data pipelines and data storage. So really our goal is, with the California Data Collaborative, is to do what we can do for them, do some of that, and also help them help themselves to the degree that they can. So just as an example of that, some of the data work, I guess, and it's really about we've gotten to the point where there's not really a lot of new water that can be had in California. It's kind of like a lot of the water has been claimed and it's there, or in some cases it is overclaimed, in the case of the Colorado River, where there's more water on paper than there is in the river. So it's really about the point, the idea of using data is to get the last, every last drop of the value you can out of the water that you do have. And so an example is one of the Molten Miguel Water District, who we work with. They were able to, through some cool demand forecasting, they were able to see hey, maybe we don't actually need to build a new reservoir for $20 million. Maybe we can actually use that $20 million for other things. So as a transition into talking about the details of Airflow and how it works, we want to start with a motivating example, which is some work that we started in early 2017 and have continued to update to this day, which is what started out as an executive order by Governor Brown, then Governor Brown, and is now a state law. There is a water efficiency framework that all major water retailers have to be in compliance with over the next several years. And it basically it sets a goal for how efficient they should be, based on the population in their service area, based on the weather in their service area, and based on the type of landscapes they have in their service area. So, for example, an area that is really dense and urban may need less water allocated to landscape than an area that is more suburban with larger lawns and so forth. So in order to actually calculate these goals, we had to pull data from several different sources. So for example, the population and the actual water use data comes from the State Water Resources Control Board, and it's also hosted on data.ca.gov. So that's one data source we're pulling from data.ca.gov on a monthly basis. Another data set for the weather variables, the variable of interest is called evapotranspiration, which is the combination of the water that evaporates out of the soil and transpires through the leaves of plants. So that gives you a measure of how much water is leaving the ground and entering the atmosphere. And then the landscape area came from a collaboration with a professor who is now at USC named Andrew Marks, who did some really cool remote sensing to basically classify landscapes in urban areas across the state into impervious area, bare soil, lawn, and like trees. And so those sort of lawn and trees were lumped together, and we're calling that photosynthetically active vegetation, which is basically a way of saying how much area we think is being potentially irrigated. And so using those three things, you plug them into the formula, and you're able to calculate, okay, this is how much water we think your agency should be using. This is how much you're actually using, so you're doing good, or you're using a little over the goal, so maybe you could be more efficient, kind of thing. So our motivating example in Airflow, and by the way, if you're curious as I talk, because I'm really eager to have your eyes off of me and onto the screens. No, not really. You can go to this link to see an example Airflow server. Feel free to click around, press buttons. It's not going to break anything. It's just a dummy server that, in a few days I'll probably take down. So if you want to get a feel for what the UI looks like. So the sort of unit of interest in Airflow is called a DAG, which stands for Directed Acyclic Graph. It basically just means directed, meaning it flows in one direction. Acyclic, meaning there's no cycles and you can't get into an infinite loop. And then a graph, meaning you have these little nodes connected by edges, and so your pipeline flows down this way. And so in our example here, we've got basically what I just described, right? We pull the supplier report, which is coming from data.ca.gov. We parse that into the format we want it to be. Then we do some stuff here to connect it with some other internal tables we have. We run, this step is a data quality check. Hey, is everything looking good? Is it all matching my expectations? If it's not, we want to throw an error and stop the pipeline right there. Don't proceed. You want to go in and debug it. From there, it sort of splits into two parallel paths that can run concurrently. They don't depend on each other. One of them is grabbing this irrigable area data that I talked about from the imagery. The other is grabbing the evapotranspiration data from the CIMIS API. It's the California Irrigation Management Information System. And so it's pulling data from that API, aggregating it to the time span of a month, and then populating, doing some averaging based on where in the state your utility, the agency is, and then again checking, hey, did everything work right? And then at the end of your pipeline, you could do whatever you want. You could even do some deployment if you wanted to. You could push your final clean data off to your open data portal if you have one of those. You could create some sort of analytics report and push that to a website that you control. or whatever. So I mentioned that the sort of nodes in that graph are, in Airflow parlance, those are called tasks. And you can see here, I'm not going to get super code heavy, but I mean, there's these things called operators that I'll get to in a sec, but you can basically create these tasks. You know, a Python operator executes a Python function, and then maybe that completes successfully. It moves on to a Postgres operator that executes some arbitrary SQL, and then that completes successfully, and it moves on to this check operator that, you know, performs a check against the data in your database. You string those, you define those tasks, and you sort of string them together, specify which ones are dependent on the other ones completing successfully. It's pretty straightforward. Use this nice little notation there. And then again, Airflow gives you all these, there's a whole bunch of operators. I mean, you could probably, if you wanted to, just do everything you wanted with a Python operator. It's just, you know, each of your steps would be a Python function, so you could wrap all your stuff in a Python function and execute each of those. But if you want to, you can use some of these more custom ones that'll, you know, get you a little closer to the workings of Airflow, I guess. You know, get to a step that sends an email. You can send an HTTP request, you know, when you hit a step. There's a cool one that we use that's a SSH execute operator, where you like SSH into a different machine and execute a bash command on that machine when you hit a certain step. So there's a lot of things you can do. You can also do, I'm just walking you real through some of the things that are nice about Airflow. And so like, I really like the connections feature, because you can, if you have a bunch of data sources, you can define them as connections just in the UI. So like maybe you have, you know, an MS SQL database over here, and you enter in your credentials, it stores them encrypted in the Airflow server, and then you can reference that connection just anytime in your code through like Airflow calls it a hook, but you just get this hook that like grabs the data from that connection and connects you to the database, and then you can execute queries against it. You can do the same thing with the SSH connections to, you know, issue an SSH into another machine and do stuff there. There are AWS commands to do stuff like to S3 or you know, to connect to AWS and do that stuff there. I guess real quick, if some of you have been looking, this won't take very long before we move into the workshop portion, but I guess this is sort of the homepage of Airflow, right? So these are all of the DAGs, all of these data pipelines that you have defined. You can schedule them however you want. So like you can use like, you know, daily scheduling. If you like cron and you're familiar with cron syntax, you can schedule them that way. And so then, you know, I want to run this data pipeline every day. I want to run it, you know, every third hour or something. You can do all of that. Click on it, go to the graph view. It takes you to this view where you can see, you know, which tasks have completed, which are pending, which are failed. There's some other stuff that is probably not going to look very cool right now but you can get statistics about how long a given DAG has been, how long each like step takes, for example. Here you go. This step takes, you know, sleeps for 14 seconds, it looks like. This is just a tutorial DAG. Connections, I talked about it here. Variables, so like instead of defining, say, environment variables on your server, you can define your variables in the Airflow UI and then just access them from in your data pipeline code. And yeah, I think that's really most of what I wanted to talk about here before we move on to the next part. So now we are going to tame the public data KRAKEN. And we're gonna sort of, like I said, you know, mock up our own DAGs, sort of, rather than make you all, you know, code up in Python an actual workflow. Probably gonna break into, groups of 3-ish, and then, if you guys could identify like maybe a use case that you have in your agency or just one that you think would be cool, maybe where you have to pull from different data sources. You could pull from, I don't know, like we have, we're pulling from 2 different state databases and our own local database, mashing it all together and doing some stuff. So my colleague Dave is going to walk you through how we're planning to do that.
Hey everybody. So yeah, we'd like to break up into groups of about 3, and what we want to do is kind of abstract away from the implementation level details of Airflow and think about the kind of logic of building a data pipeline. So we'd start there by defining some kind of data integration task. This could be ending up deploying to a visualization, to an open data portal, doing some processing task internally, and thinking about all the different steps along that process. So to kind of show what that looks like, we can take our statewide efficiency explorer example, and we'll start with defining what the problem is. So we have these templates here where you can give it a little name. So the story narrative here is the statewide efficiency explorer. And then we want to break it up into, okay, this could be, in this case, it's as a data scientist working for the CADC. I want to integrate this CIMIS data, these local environmental conditions, the conservation reporting, which is usage and population, and landscaped area data. I want to integrate all of this so that I can deploy this open source analytical tool and do this benchmarking for all of California's urban residential water usage. So as a team, you can define, you could be a single analyst, you could be a team within an agency, define what you want to do, what data integration task, and the purpose of that. And then we have some cardboard here, as well as templates for the different types of data integration things you might want to do. So Chris kind of talked about the different steps along the statewide efficiency explorer pipeline, but what they would look like here: pull from an external database, write to an internal database, pull from an internal database, do some calculation, do some processing, do some data quality checks. So we have these different templates, and the idea would be with your team, take this data integration task, break it up into each extraction, transformation, loading, the different tasks along the way, and build out this pipeline. And then Chris, Pat, and I will be walking around, and we can talk about any questions or anything like that. So let's make some teams, and we can also ask some clarifying questions before that.
Make friends, find teams of 3.
We could just pull maybe you can pull his seat or something, or we could just maybe talk across.
It's just a logic. package simply as. Yeah, there were 10 of them. So we have any.
A lot of DAGs. I thought it was, it looked like,
So,
is everyone
Is there
have
any-
TAME? Or,
so
what do I say?
is there one group without these then?
I think there's not 10 groups. I think there's 1, 2, 3, 4, 5, 6, 7 groups. The Infinity DAG. It's like Thanos, the Infinity DAG.
So,
Should probably tell them. I don't think we give them a time to come back.
Consolidate.
So right off the bat, we got
No, there's a way to extract it. Yeah, so I get company, but I don't. So we're able to get the data out. I don't know how the data is related. I don't. Right now, I'm still doing this.
Yeah.
I also just now got sort of reversed with the code. So I'd like to
Why do they?
we were like on Google Flights.
How much?
Definitely closer to no, that's fine.
They know already up front.
So where does the workers' compensation? We did left to right.
Well, they already have our own thing with solution, but they already have. We already have. And then you'll pull these three.
Feel free to write.
You gotta put them into ARGO.
And then what I would do is I would.
Sure.
So I try as much as possible not to say things. I try to like Because if like one of your steps fails, like I want people to do it. I don't want to have to run that story. Like maybe we'll do some things like yeah, or it would compile. But so actually, I meant to talk about that. So like, in practice, the DAGs is called ETL. It's like a math word. I mean, in math, you can apply a function more than once to get the same result. But in the case of the DAG, it's like if you run the DAG once, you should not get different results. So like a good example of why we want this is we have not actually we're like if you run it once, statistically where then you try and run it again. So it's like
yeah, I mean, this is what I have right now is on
towards the, like not doing any of your logic. You heard of block just the other day, it's like, they were like, oh yeah, all of your tasks, they were talking about, more engineering side of right, but so it's like, right, so the basic idea is like, you can imagine if you bring it to the bash, all of your bash, right, like run logic and because not every
You flatten everything out. Yeah.
Based on if it's not gonna
Basically, you get your criminal report back. Background check.
harder in Python, like try and use where you can basically catch failures. You really want to do something like this. If you detect where they are, then go and skip that before the task is and then you say, hey, test. That way, it's sort of resetting yourself. Or like, if you're writing to a database, where like
essentially,
you start the transaction.
when they're getting it, they don't look at all that stuff. That's our job. So they're just saying like, what's the most important stuff? So we're synthesizing.
Otherwise, just like, oh, I don't want to send that. So that was the motivation of the and then sort of getting the second so let's say you go that way, you would start the process
How
of
can I get it through
then what you see, in that the UI green nodes to be read, you can go in there and click on the log, you can actually see the log, see where it went wrong with the UI without having to like connect to the server. Yeah. What do you guys do?
But it's like
So one of the things we do also in Python is open source.
So we can write a script for this.
Change it we do it free. So all that stuff.
Solid, it's good. What do we have?
Oh, we can go down. It's almost like saying,
Yeah.
Oh, cool.
Testing, testing. Sounds like it's working.
You do.
Yeah.
That's the weights that measure stuff.
Well, I guess some people are still trying.
Because that would give us ending 5 minutes.
I mean, so Emily was suggesting that we need to get out like 15 minutes or whatever.
For sure. Okay.
I've actually seen like
A lot of that stuff.
like join line. They were a little skeptical at this, but I think that
Yeah.
Would you prefer to have the camera view on the screens or the laptop on the screens?
laptop, please.
Okay.
Okay. Maybe, I think we're getting close to the share out point. Most of the groups are getting kind of there. So when you're ready, just maybe make a little notify. 5:15.
But we're planning to end a little early.
Yeah. Which gets you sooner to happy hour. Which no one would do. You're just jetting out. Yeah, I do too.
Yeah, I do too. My train doesn't leave till 6:40. So
Yeah, really?
oh yeah.
You guys are done. Figure out how you want to present it.
Oh, we got a TM.
That's a thing.
Yo, I gotta do Toastmasters, man.
Right.
So why former? What happened? I asked because
Is there everybody? What do you do? No, she's an
Nina is.
Gotcha.
so.
Gotcha. And what do you do with the audio controller?
It's Toastmasters.
Right. Like an internal dashboard. Kind of.
Yeah.
Does the reporting take a lot of like manual steps for your staff? Okay, that's good.
But,
Oh, you want to?
all right. If people could sort of, I think we're gonna try and do some closeout. Have everybody share some of the cool data integration projects that you have worked on. So who would like to start? I saw two hands, but you're close.
Some sort of dashboard.
All right, good afternoon. This is our tremendously difficult diagram, yes. I know you're all very impressed. There's almost 10 things on here.
Yeah.
So what it is we call it the pesticide use data aggregation. For my department, agricultural commissioner, There's a state website where everybody has to put in their data, but unfortunately they don't track about 10 items that our department tracks. So they've been double entering data since they put it up for about 5 or 6 years. So now that I work there, I went, why are you typing things in twice all day long? And they looked at me because, so I said, okay, let's figure out if we can get a data extract. So there is a way to get the data out of their system into Excel. And then my data is in DBase 3. And so I'm going to put both those data in MySQL, join them together, join here, try and clean up the data, make sure it matches, geocode what I can, and then I'm giving a web front end for them to modify the data that we do. That was it.
My partner Kevin and I, we came up with a process for assisting hiring managers on evaluating potential employees' criminal history. So essentially you create a file that you add into your already existing database. You pull from local, federal, and state criminal databases, check the quality of those data. And what we mean by that specifically, you not only see if they've all been entered in a uniform fashion, but you'd also check on the status of those offenses committed, and then you combine that, join that with the database. From there, you update your database and your report, and then you determine whether or not this person goes in the non-employable and employable, and then you send it out to hiring managers of other departments, and that's what.
All right, so we have streamlining transportation projects. So first thing, we're pulling data from the Los Angeles Department of Transportation, Metro, anything that affects the roadway, and trying to get that data in a standardized format with the fields we're interested in, which is basically where they are and when they're going to take place. And then data quality check at that point. If the data isn't already geocoded, geocode it. Check that. And then we're pulling data from other sources to create a prioritization score for these projects for the city. So look at whether they're on the high injury network, whether they're in areas that have historically been underinvested in, look at land uses around there, and then create a project prioritization score, and then push that clean data out to the public.
Awesome.
All right, so we are reducing violations through information. And what we're doing is we're combining permitting data and violation data from some internal databases and doing a data quality check on that before joining the two together. And then we're going to geocode that. So we understand and then calculate some hotspots to understand where a lot of violations are happening, along with where development in the city is happening. Adjust for population density from census information, and then have it output a dashboard for the community development director and the information officer, so that they can lead education efforts in these areas.
Hi, my name is Christina from the county with Tony Trin, and we are, what we plan to do is to, so the issue is there are people that are being going retirement in the county, and so their process has not been transitioned to a more centralized process. So there are multiple different providers, different systems that we need to collect, and this data needs to be cleaned. And then so when they enter our system, so we do have we pull client data from provider system, from multiple provider system. And before we do data cleanse, we write raw data to a data warehouse. We dump them to data warehouse first before data cleansing and doing some calculate record counts to make sure that before it gets joined into a master database file, we have logs for that as well. And then we do data quality check before it gets deployed to a production so that a clean data and a more effective data and accurate data is provided to the users. So yeah, that's it, yeah.
Hi, I'm Jody Tan from ISD and Tiffany and Malawan. So for us is we're grabbing some data from workers' compensation data. So basically detecting anomalies in the workers' comp. So first thing we did was we basically pulled data from the source, which is the risk database. And then from there, we'll write it to the Hadoop data base, which is the target. And from there, we'll look at do some data quality checking to make sure the records are basically the same number of accounts between the source and the target. And from there, we'll calculate the anomalies, which is the total number of occurrence there is anomalies versus the total number of claims that's there. So that would be the percentage of the anomalies. And then we'll join it. Then we'll join it to once we got that result, we're gonna basically push it back into the database and then using Power BI as a visualization. So at least they can look at where the anomalies are and then drilling down to the detail of every single claims that they need to.
So we are making a map of agricultural water use efficiency for certain areas in California, starting with data on irrigation deliveries or possibly groundwater pumping, depending on the district, which you could pull from many irrigation districts' websites, either through an API or through scraping them. Then to get at how much water the crops are actually using, we pull some Landsat imagery, which is public domain, and put that into a model that can calculate evapotranspiration. And then the third piece of it is California CIMMYS data, which is sensors on the ground that measure evapotranspiration at specific points on the ground. We QC all of these. We push the Landsat imagery through the model to turn it into ET data for each pixel. And then we combine all of that with a shapefile of the actual field boundaries in the particular district. And the result is a map of irrigation efficiency, basically how much water are the crops actually using compared to how much water was actually used to irrigate the crops.
Great. Well, that was cool. I'm glad that worked because we weren't totally sure, but just being honest. Thank you. I guess we're a little early, but that's fine because so Emily, who was in here, has been coming in and out, helping with running the show, said that I guess some people were interested in seeing the sunset from the rooftop bar, which right. So, which I guess is supposed to happen around 5:22 or 5:25 or something. So you'll wrap up here and everybody can go do their thing.
Just time check. It is 4:52. You guys are cool. You can be here until as late as you want, and we'll see you upstairs later.
Sounds good. And so the install guide is from one of kind of our oracles of Airflow, who's Varun Adibatla, who's not here with us today. But so there's like a nice little getting started guide in terms of like installing it, all that kind of thing on your local machine. So if you are like, hey, I actually want to do this, that's a useful, helpful one. There's stuff with Docker. And then you can always drop us an email. We're happy to help you out. So,
Precious slides are gonna be available.
yeah, I think they all will.
Yeah,
They're like
yeah.
in the thing, in the folder. Yeah.
Yeah, they'll definitely be shared out. I also put a bunch of random reading on here for those who are interested. I mean, the main Airflow website, and then a bunch of like Medium blog posts related to Airflow that sort of get to stuff the main site doesn't. So if you are interested in diving in, there's lots of context here. So thanks for coming out.
Yeah.